We are from Group30 and our title is Smart Home Power Control System. Our problem statement is the lack of control over power sockets results in devices being left on or plugged in when not in use. And the second problem statement is the difficulty in tracking power consumption patterns and identifying inefficiency or issues. And the third problem statement is the risk of electrical accidents due to the lack of monitoring for anomalies like voltage fluctuations or overload. The first objective for our system is to remote control and monitoring of the power usage. We aim to develop a system for remote monitoring and control of power usage to reduce energy wastage. We want to enable users to monitor and manage power consumption of individual devices remotely. And our second objective is to enhance the safety of users' house. We want to integrate monitoring capabilities to detect anomalies and prevent electrical accidents. The third objective is notification system integration. We aim to implement a notification system to inform users about device status and the house conditions. We enable users to take timely actions, troubleshoot issues remotely, and ensure efficient operations of home devices. This is our system architecture diagram.
Morning, I'm Nicholas from Group30, and now I'd like to show the configurations of IoT core. So firstly, in the service, we need to search the IoT core here. And the first thing that we need to do is to create a policy under the security section here. So we create the policy. So the policy name, we can choose any name. So we can put it like Smart H policy. And under the policy effect, we'll put it as allowed. And for the action, we'll put all action that we can use. And the policy resolves also all. Then we create it. And then it already is created. Then next, under the all device, we need to create our thing, which is the IoT. Then we create the thing. The number of things to create, we'll set it as single thing. Smart. Then under the additional configurations, we don't need to configure anything. And for the shadow device shadow, we put it as no shadow and proceed to the next step. Under the device certificate, we will choose the auto generate a new certificate. And the attach policy will attach the policy that we created just now, which is the Smart H policy. Then we will create. After we press the create thing, then it will pull up a download certificate and keys, which we need to download all of it. Then next, we need to, under the VS Code, we need to open a new folder when we need to do some configurations, which is to search the GitHub IoT, AWS IoT device SDK, and we will need to do the installation, which is follow the instructions. And after the installation is done, it will show this as, you will have some new folders right here. So this is the JS file that I already created. So the next thing that we need to do is to import in the certificate and keys that we downloaded just now, which is this one. Okay, after we have imported all the keys that we downloaded just now, then we under the key path right here, we can copy the key path. So for the key path is we're going to use the private key. And for the third path, and this is we need to rename the extensions to .cert and copy it and paste it as the third path. Then for the CA path, we're using the CA1 and paste it here. So next is on the host part. So for the host part, we'll need to go to the under the test, we'll have MQTT test client as we are using the US East region. So under the connection details here, the endpoint we'll have the US East 1, which is the host. Then we insert into the host. And that is all for the configurations of the device and the IoT SDK. Then next, we need to configure the connections of the topic. So for our script, I stated that the topic name is smart, and for the MQTT client, we need to subscribe into the smart topic. And now we are successfully subscribe into it, and now I will run the JS file. So in the configurations here, I set that if it is connected, then it will also connected to AWS IoT, and I set the timetable into 1 second, so it will constantly pump the data between 1 second. So now here is the data that pump. And after we notice that everything is done already, then we'll proceed into the message routing, which we need to set rules for the data to pump into the to insert into the DynamoDB. So for here we'll have a rule name data from Smart. Then the rule description is optional, so we can write it as data that receives from Smart to DynamoDB. And press next. The SQL statement that we need to configure is to select all from the topic, which is Smart. Then entering to the attached rule action. So the actions we need to do is to insert into DynamoDB v2, which we split the message into multiple columns. Then the table name, which is the created table power plug, and for the IAM role, so we apparently still doesn't have any role yet, so we'll create a new role. So db read write. After it successfully created the role, so we need to view the role because we need to attach some policy into it. So in the add permission here, we attach the policy. So the policy that we need to attach is the Amazon DynamoDB full access. Then add the permission and check whether it is successfully attached or not. After that is done, then we can proceed to the next. And the last step is to review and create. Then after we review then nothing, then we can create. Then the data from Smart Hooker is already created. And next we will proceed into the DynamoDB, which we need to check that is it the data successfully inserted into the table. So on the table, and this is the table that I created, which is the power plug. Export more table items. After we enter to the export the table, then we will see the items that are written, which is the data that we pump in, which is the P003, which is same as this. Plug ID, then the P003, and then we can ensure that the data is already pumped into the DB. And that is all from me. Thank you.
Hello everyone, my name is Loyal White, and my student ID is 2003029. And I'll be presenting about how we notify the users. Okay, so first, we insert data from the IoT call to the DynamoDB, it will trigger a Lambda function called send notifications. And inside this Lambda function, we have the following code. What the code does is that we will publish messages to SNS topics under several conditions. So the topics are device connection notification, humidity notification, and temperature notification. Now back to the function. We have several conditions. First is when the socket is on, but no devices is using it, we will notify the users. Or the device is not connected for more than 10 minutes, we will notify the users. For temperature, if the indoor temperature is under 22 Celsius or over 28 Celsius, we will notify the users where it may be too cold or too hot. For humidity, if the indoor humidity is under 30% or over 50%, we will notify the users where it may be too dry or too wet. Okay, so let's test this function. This will be a test event where the socket is on, but no devices is using it. So let's test it. Successful. Okay, meanwhile, we wait for the message. We will test another event. It is the data from the air conditioner where the indoor humidity is 29, same as for the temperature. Okay. So let's test it. Okay, successful also. So let's check our email. Okay. We have your device, television 1 is not connected. The indoor temperature is 29 Celsius. It might be too hot, right? And the indoor humidity is 29%. It might be too dry. Okay, that's all from me. Thank you.
My name is Lau Xin, and now I'm going to present the part I've done in this project. In my part, I've implemented Lambda function, API gateway, and also the Amazon Cognito. Here are the three functions I've created. The first function is socket info function. So by using this function, users are able to get all the data from the table called power plug in DynamoDB. In control socket function, users are able to turn on or turn off the socket by updating the IoT device schedule. In control aircon function, users are able to control the temperature, mode, fan speed, and status of the aircon, and also by updating the device schedule of the IoT core. In API gateway, two APIs created. One is socket info API, one is control socket API. In socket info API, there are total 4 routes, and all of these routes is integrated by the socket info function. For control socket API, here are total 5 routes, and for these 4 routes under the control is integrated by control aircon function, and for this route is integrated by control socket function. So here is the user pool we have created for the Amazon Cognito called Smart Home Pool. So after signing in with the username and the password, we are able to get the ID token and the access token. So now we are going to test the API. And at first, we need to do the authorization. In this token part, you just need to copy the ID token we get here just now, and then place it inside. Now we're going to test the control API with the socket status. So this is the IoT device name. So now we're going to change the socket status to off. Send a request. Okay, now it shows it's updated to off successfully. Let's check. Okay, you can see here the schedule is successfully updated to off. Now we're going to test the socket info API, and then we test the get socket info. So we're testing the socket with the ID P001, send request. So here are the records of the socket P001. Okay, that's all for my part.
For the DynamoDB, the data passed in from IoT core will be stored inside the DynamoDB power plug table. And as we can see here, the data is stored in the DynamoDB table with the plug ID, timestamp, detect in use, device name, power consumption, and status. And for the Dynamo to S3 Lambda function, every time data is inserted into the DynamoDB, it will trigger this Lambda function to run. And the function for this Lambda function is to pass the data from DynamoDB into the S3 bucket. And this will be our S3 bucket power usage management. And we have 4 folders, which is backup, date, forecast, and quick site. And for the backup, the data stored is everything from the DynamoDB, all the data as like in DynamoDB. And for the date, the Lambda function will separate the DynamoDB data into different dates, and then within that date, it will only contain the power plug that has been used in that date. So it's more easy for users to see. And for the forecast is the data that will be used in the Amazon forecast, and the quick site it is separated into different power plugs. So this power plug will only contain the power plug data. This is our Amazon forecast, and the item ID that is forecasted is the plug ID 1. And from this graph, we can see there is a P10 forecast, P50 forecast, and a P19 forecast. A P10 forecast means that it has a 10% of possibility it will reach around 315 power usage at this time. And a P50 forecast means it has a 50% of possibility it will reach 350 power usage around this time. And a P19 forecast means it has a 90% of possibility it will reach 400 power usage around this time. This allows users to modify, identify, and forecast their plug ID so that they can know how the future trend of the plug's power usage are going to go, so that they can make modifications about their current usage and save power energy. And this is our Amazon Quick site, where our x-axis is the timestamp and the y-axis is the power consumption. And inside it will be the plug ID 1 and the plug ID 2. And from this graph, we can see that the power consumption during this time is especially high and it's spiking up. That might be indicating some voltage fluctuation or dangerous activity in the power socket. So users can monitor it to prevent any further electronic incidents happening on this plug. That's all from me. Thank you.